Hello, everyone. Welcome back to the AAS YouTube channel, and we're going to continue with another module in the Teaching Online Tools and Tips. And the topic of this module is going to be planetarium and planetarium-like programs that you can use for your online teaching. Chris, why don't you go ahead and start off?
Okay, sure. And I guess, I'll start with one that's not a traditional planetarium program. Well, actually, I'll start with Stellarium because that's pretty classic open source planetarium software. There are a number. I mean, if you Google planetarium software, there's a lot out there, and it does get a little bewildering to choose. They all have a lot of features. They all seem to be pretty capable, but Stellarium is I would say a tried and tested package. It's free, it's open source, runs on all major operating systems. It has all the visible sky objects, of course, but also, catalogs from Hipparchus and Tycho 2, and 200 million. I think it has an overall capability of 200 million objects if you really want to go crazy. So it definitely can handle deep sky stuff and more than just the visible night sky. It also, I think this is a little detail, but it has constellation maps in 10 different cultures. So you don't have to be, anthropocentric or about one particular culture naming the sky. The mobile version is pretty good. I've used it. I haven't used it on all platforms, but it will run on iOS and Android and Symbian and so on. So Stellarium's a pretty good place to start. You
so I'll pick up. On my own side, and I have used in the past because we got a price break on it because it was sort of in volume. Was using Starry Night, which is a commercial product. It's great. It's got every bell and whistle and everything you could imagine. So it's a full feature planetarium.
And just as an aside on that, in the distinction between free and what you get when you pay for something, I mean, I've used Starry Night too, and it's a very mature product, and I guess the benefit you get for paying for it, they have good, pretty good discounted pricing for big classes and so on, and sometimes your institution will discount the pricing. I think the secret sauce it has is it has a lot of lesson plans and pre and post assessment resources. So it's sort of pedagogically more built out than just, oh, here's a sky viewing tool, go look at the sky at this time or watch an eclipse or look at this conjunction of the planet or whatever.
Right.
So it's sort of bundled into an instructional framework that I think many people would find useful.
Yeah. If somehow that's not in your budget, or it's not in your institution's budget, or maybe it is, but you can't get there quick enough over the next few days, other options, there are a number of reasonable, I would say, not as full-featured as something you would run on your laptop or desktop or mobile device, but there are online planetariums that can be useful. So examples would be Stellarium has one, In the Sky. .org is also another pretty good one. Star Atlas. If you want to stay a little bit more focused on the Earth and the Moon, Google Sky is okay. It's certainly not as full featured as some of the ones I just mentioned. But there's enough there that you can do interesting labs. And if you've never used a planetarium program in your courses, I think you'll be very happy with the student response, the student learner response, because in some sense it sort of makes it real, more real for them. So examples of labs that I have run using these software include things like, angular sizes on the sky, right? The moon is 1/2 a degree. Go ahead and measure it. Now suppose you are on Mars, go ahead and measure it. And so it can really help drive that angular size component that we all generally teach in the intro courses, bring that a little bit more hands-on and real. Reason for the Seasons is a good one to do in these planetarium courses. Doing Kepler's second Kepler's third law. These are good ones to do in a planetarium program. You can also do Bode sequence if you like. That one tends to be a little bit fun. On a little bit more advanced side, I've done things like the precession of Mercury's perihelion is doable. It's a little more exacting. You can also, the other one I haven't personally done it, but I've had students do it as small project groups, is they've taken some of the old, well, I shouldn't say old, they've taken some of the Greek observations for what is the size of the sun, Arcturus, and other of those observations, and try to reproduce, what they did or what they were attempting to observe given their technology limitations, but reproduce those experiments in a planetarium, right? Discover that the sun is 400 times farther away than the moon, or things like those. So you can definitely do these kind of things these even on the online versions of these planetarium programs.
Oh, and as a little a tag on, you mentioned Google Sky, and I agree, it would not necessarily be my first choice, but two related resources that off of Google Sky are they've put, as only Google could really, NASA could but didn't, they've got these incredible zoomable high resolution maps of the moon and Mars.
Oh, LROC kind of stuff.
Yeah.
Yeah.
And the moon's includes 3D models and panoramas, and it's really immersive and very cool stuff. And you might find a use for it. Just go and explore it. I mean, I'm not suggesting exactly how you might use it in a class, but you might well think of an idea once you see it.
Or turn it loose on your students and let them be creative with it, and you might be surprised what they come up with.
Yeah, just have them make it like a treasure hunt for geological features on one of those two bodies or whatever. You get them crater counting. There's a lot of possibilities.
Now let's estimate an age.
Yeah.
Oh, I love this.
Okay, right.
Yeah, this is a great idea.
When was that heavy bombardment?
Okay, I haven't done that one. That one's a great idea. Very good. The other, go ahead.
Yeah.
Okay. The other kind of device that you may want to consider, and students get a big bang out of it, particularly if they are not familiar with the night sky at all. There are a number of these augmented reality programs for mobile devices. So let me see what I got on mine. Let's see, I keep a couple on mine even. I use SkySafari Pro and StarWalk, and these come in both free and paid versions where you get a little bit more capability. And if you've
and paid here $5 typically.
Yeah, a couple dollars. We're not anywhere near to like Starry Night kind of prices.
Right.
But yeah, so if you've never used one, check it out. It's pretty amazing actually. You point it up at the night sky, and it will through the GPS auto identify where you are and what your location is, and then identify what you're seeing on the night sky. So it's a great learning tool. You can send students off on to pick up the point you made earlier, Chris, on exploring the moon surface is have them do basically a star party, right? Go out and see how many of the planets you can find. Go out and see how many number of Messier objects you can find. Lots of things you can do with these augmented realities. And then you don't have to worry about them. Well, I can't figure out where I am. Where's north? So nice. So consider using those. I've used them. They great impact.
Right. Another option is, which some of my colleagues, not that many, have heard of actually, is the NASA Micro Observatory. I mean, this is a very particular way to use a resource. So this is a network of robotically controlled 6-inch telescopes that take images not for research, just purely for educational purposes. It's funded by NASA and developed by the educators there were from Harvard Smithsonian Astrophysics group. And it's mostly, the network's mostly been used at high school level, but it's really great for non-science majors to get a taste of real observing. And basically the model is you put in a little observing request for a set of objects that a 6-inch telescope can observe. It's only, of course, the very brightest galaxies and Messier objects typically, but some star clusters, nebulae, interesting. And the students, in making the little miniature observing request, they have to know enough you know, to realize whether the object is visible at that time of year. They have to understand the field of view of the observation. They sort of learn in a guided way about the very basics of observing. And at the end of all that, they get their own data. You know, they get an image sent to them. And okay, to a professional astronomer, it's not that impressive with a 6-inch telescope, but it's their image. And to get them to go from the beginning to end of deciding what they want to observe, whether it's visible, putting in a miniature proposal to the network, getting the image, and then writing a little report about it, it's kind of cool. I mean, it's a little project that you can insert into a class that gives them a sort of taste, if you like, of getting their own data and doing observing.
Yeah, I could. Yeah, that's interesting. I could see doing something. I mean, you're probably not going to get Pluto with a 6-incher, but you could replicate, you know, sort of how Clyde did that, right? Maybe it's Mars, or maybe it's a moon of Mars, depending on what the capability of the scope is. But you know, sort of discover stuff a la Clyde in Pluto, and you know, maybe even have them do the blink comparator image and the whole bit.
Right. And this is not something we're suggesting for this urgent moving online, get your together. But, you know, just for the future, bear in mind, if you get a taste with, say, the micro observatory, bear in mind that high school students, I think a year or so ago, from 7 states used the network to detect transiting exoplanets, you know. So, you know, you can do actual research with these tools now. As we know, a lot of exoplanet research is done with pretty modest tools. Some modest sized telescopes by a professional astronomer standard. Anyway.
Yeah, and just pick that. Let me just throw a little thread on that. You know, we're all sort of being pushed to be online right now for good reasons. But it may be that this is not just a 2-week change of pace, right? It could be that this will go on for next semester and the semester after that, not necessarily because of a pandemic, but for efficiency purposes of a university, you may also find that you really love teaching online because it opens up all kinds of capabilities for you. So yeah, so some of the things we're talking about are not what you're going to do if you got to get something up in 2 days. But once you get something up and you're going, things to consider as you maybe further your trajectory in online teaching.
Well, and also, you know, let's get real. You were worried about this semester and getting through the semester, but our university has already pulled study abroad and is telling people to go online in the summer session. And if we don't flatten that pesky curve, we're talking about the fall semester too. So you should already be thinking ahead.
Absolutely.
Get through the semester for sure, but start thinking about the fall, and it may again not be an option for many people.
Yeah,
it may be mandated.
And like anything else, once you do it once, it's easier the second time, third time. By the time you do it 3-4 times, you're almost a master, and you can begin experimenting with things that work in your courses.
I think we had one other. I think we're wrapping up, but there was one other resource that we probably both have something to say about, which is not quite exactly planetarium software, but it's an impressive project, Worldwide Telescope. Do you want to talk about it?
WWT. Thank you. Yeah, so check out WWT. Again, I'm going to put links to a lot of these things down in the video description, a number of the planetarium programs we talked about, and one of those will be WWT. So WWT is a project run by the American Astronomical Society. It is really great for visualizations and looking at objects in the sky and in the deep sky. It was originally a Microsoft product a number of years ago, and the AAS picked it up a few years ago.
And critically, when it got taken, you know, when it got adopted by the AAS, it was sort of orphaned by Microsoft, actually. It was a pet project of one of their famous developers to astronomers. So it was a Windows application, but now it's got a web client. It's used in a browser and any desktop handheld device. So it's open source, you know, as most of the things we're trying to talk about are, in fact.
Yeah, and in its current state, it's not a planetarium type program per se, not like some of the other ones we talked about, but it is definitely a resource to check out, go ahead and check it out. Also, if there are features in WWT that you would like to see, drop them a line, send them an email. They're open for suggestions right now on sort of the directionality of where to take WWT. So maybe it's more in the online education arena. Maybe it's more in the research area. So yeah, that's another resource you should check out.
So, just to follow up what you just said, in terms of the way you might imagine using it, it definitely does have a mode where it's just like a planetarium viewing tool with constellation maps and control of time and location on the Earth, just as you would expect. But it's also got these, massive data sets attached to it. It's got all the Hubble, Chandra, Spitzer data, IRS, Fermi, Galax, VLA, WMAP, whatever, name your mission, it's all in there. And so you can, hop to multi-wavelength views of particular objects, Messier, particular bright galaxies or active galaxies.
Mm-hmm.
So you can do very focused things with it. And I think the best way to experience how some instructors have worked with it, which is a development path that I understand is not for everyone, and especially on short time scale. But what is really good is for making what they call tours.
Yes.
So basically it's like a guided exploration where you actually record with your own narration. You can add music if you want, your own video, your own voice, a tour of the sky or some phenomena of the sky or some aspect of astronomy like active galaxies or whatever. And I think on their website, there are 50 plus tours there to just give you the idea of what you can do with it. And you basically can these things, and they're like canned multimedia presentations that embed this planetarium-like but super turbocharged capability. So it's a pretty impressive tool.
Yeah, I was just let me follow on with that. It's also not necessarily that you do that. You may have students in your courses that are particularly adroit with computers or have a computer science interest. That can make great advanced, projects for them to go ahead and to go ahead and craft one of these tours and then go ahead and make it public. So these are just options to consider for the types of students you might be teaching.
Yeah. Well, I guess that's our fire hose here. Oops, sorry.
Very good. So thank you everyone for listening in on this topic on planetarium and planetarium-like programs. And we will see you on the next ones. Thanks. Bye-bye.
Bye.